Okay, my talk today is concerned with a fairly pervasive issue. How do you make investment decisions when you're uncertain about what missions will really require? And you're also uncertain about the technologies that could meet those requirements. How do you manage these two aspects of uncertainty? Next slide. So we have an issue of the uncertainties that we're concerned with. And we're going to compare the automotive and defense domains. The reason we're doing this is because our example case in this presentation is the automotive domain and autonomous vehicles. And we chose that because we actually have access to the information and data we needed to do this example. And then we're going to talk about a strategy framework and compare uncertainties in the two domains and what strategies we could apply. We'll then look at our overall approach, the underlying model structure, the representations employed, and the notion of an uncertainty management advisor that we're in the process of developing. Then we'll get into our autonomous vehicle case study, and we'll talk about market needs versus enabling technologies. We'll talk about OEMs, investors of attributes. So the user in this case is the automotive original equipment manufacturer, and we're concerned with how are they going to make investments, or how should they make investments, and we'll come up with an overall investment strategy. So we're first going to talk about what are we concerned with, what are the phenomena involved with approaching this problem. Again, the problem is how should we invest in autonomous vehicles. Then we're going to talk about the strategies, the uncertainties associated with these phenomena, and then about the strategies for approaching those. And again, we'll compare automotive and defense. So here we have the automotive and the defense domains. And we've broken it down by the economy, the market, the company priorities, and the vehicle itself. And on the defense side, the geopolitics, the economics, defense priorities, and the platform. The reason for doing this is because even though our example is in the automotive domain, the commercial automotive domain, we wanted to show that our line of reasoning applies to the defense domain as well. And I think you'll see a reasonably interesting and compelling comparison in this slide. We won't go through the details on this. So now the question is how to invest. And traditionally, financial analysis and other kinds of mechanisms look at whether to invest or not. We're not going to consider that. We're going to consider how should we invest, what types of investments should we entertain. And as you'll see in this example, we end up with 3 investments, not 1, as a result of the analysis. So if the objectives and dynamics and constraints are measurable and tractable, then you should just optimize, do the absolutely best thing you can. Now, the difficulty we have is that we're so laced with uncertainty that we probably can't do this. And we'll see there is one example where the OEM could do this in their traditional business line, but the other examples don't fit this. Another possibility is that your response time is less than the external response time. So whatever happens in the world in terms of adversaries or competitors' actions, in terms of technology developments and breakthroughs, you are faster than they are. You can respond immediately and be ahead of them. Then you should adapt. Another possibility is that you're not that responsive. You can't act that fast. Okay, but you have multiple viable alternative futures. You can think of different scenarios of what will happen, and you could invest or hedge against each of these scenarios. So this would lead to multiple investments, but smaller investments than an optimized would involve, for example. And you'll see that's what happens in our example. And finally, you get to the point of accepting. You can't optimize, you can't adapt, you're too slow, you can't hedge, you don't know about the future. Then you really have to wait and see how things play out. So what are we uncertain about? Okay, well, let's look at this one in a little more detail. In the automotive domain, we're really concerned about customers' future preferences. For example, right now, they don't want to buy cars. They want to buy SUVs and pickup trucks. The defense domain, we're concerned with whether mission plans remain relevant. Is that really going to be the mission when we roll the platform out, or is things going to have changed? On the automotive domain, We're concerned with customers' future purchases, and we'd like them to favor our offerings. On the defense side, we'd like our mission platforms to remain superior to adversaries' capabilities, which may be changing. On the automotive side, we'd like our performance of our offerings after development to be as we expect. Same thing on the defense side. Affordability is an issue on both sides of this column. Budgets across a range of future needs, we need to be able to be sure to that. We need to understand whether our supply chains will be economic, efficient, and secure. We understand, we want to make sure that our competitors' capabilities are not perceived to be superior to Rouse. Similarly, the adversaries' capabilities will be inferior and certainly not superior. So these are very parallel situations that we think both can be addressed with the methodology we're about to introduce. So here we have a portrayal of requirements uncertainty versus technology or feasibility uncertainty. If we know something is definitely required and we know how to do it, then we should optimize because the uncertainty is very low. On the other hand, if we're not sure it's required at all and we're not sure how to do it, we should definitely accept, because what would we do otherwise? But in between, we have some interesting ones. Right below optimize, you see we should adapt if the possibility might emerge, and we know how to do if it does emerge. If the possibility is not required at all, but we fully know how to do it, in the commercial world, you'd license those patents to somebody else. As we get down to the point of where we're not sure it's feasible, but we know it's not infeasible, then we look at hedging. If it's definitely required, we'd hedge via a larger R&D investment. If it's possibly required, we'd make a smaller investment. If we're in the left column where we don't know how to do it, but it's definitely needed, then we need to hedge via a partnership. Similarly with possibly required, maybe with a little smaller investment. So this is how we balance out the two aspects of uncertainty with the optimize, adapt, hedge, and accept model. So how are we going to do this? Okay, let's dig in. First, here's the model structure. So we're basically using a mixture of quality function deployment, design structure matrices, and case-based design to characterize who are the stakeholders in this market or who are the stakeholders for this mission and what's important to them. Validity, they want a solution that actually works. Acceptability, they want a solution that fits into the other ways they do things. And viability, they'd like it to be cost effective and worth it. And so our stakeholders have preferences. We also need functions that deliver the attributes they're concerned with. And we need solutions that are composed of functions. And by the way, these solutions are not going to be just our solutions. They're going to be the competitors' solutions, the adversary solutions, at least the ones we can imagine, because we're in a competitive environment and we're not the only one playing this game. So these are all the classic papers that support the underlying mathematics and trade-offs of what goes on in that model I just presented. So we're building on a lot of very solid structure, and we're building in a way that we can make this all computable and interactively computable is the plan. So we're working on a thing called the Uncertainty Management Advisor, and this is just being developed. But basically we have two parts of it. One is the model specification, the parameter selection, and the relationship that are involved, and those are from that chart I just showed you. But then we want to execute the model. We want to compute things about it. And we both want expert advice. We want some AI built into this to help us to do this execution. And we want model curation. So I've done some of this before with semiconductor companies, and we planned 7 generations of semiconductor products just building on the same model over and over again. So you really get to capture the knowledge in the organization. And then the final thing on the right is sensitivity analysis. We've always made a lot of assumptions in developing some of these models. We want to find out which ones really matter and either empirically validate those relationships or at least be sensitive to their impact on the outcomes. So the autonomous vehicle case study. When I first talked to Scott Lucero about this project, I said we need to have a case study. We can't just do this in abstract. And so, why are you interested in this? He said, well, it depends on the procurement. I don't know what I can share with you. I said, why don't we do it on something that I know about already? I've been working with General Motors for years on vehicle systems. We're currently entertaining the issue of autonomous vehicles and where should GM position itself in this. And they're willing to share all the information I need to do this modeling project. So he said, well, it's vehicles and it's autonomous vehicles. It's close enough. Let's go. So we conducted 3 workshops in Washington, D.C., focused on the accessibility of driverless vehicles to disabled and older adults. These were conducted in 2019 over the course of the year and had all the automobile companies involved, all the government agencies, the various advocacy groups, the technology groups, et cetera. There were over 200 people participating in the 3 workshops. And the question was, what does the autonomous vehicle have to be like so disabled and older adults can utilize it? You may not know this, but in the United States, there are 100 million disabled and older adults, and that percentage of the population is growing. So about a third of the country needs transportation to get to work, to go to the grocery store, to go to their doctor's appointments. And the question is, how can we, as an automotive OEM, address that market? So we know pretty well what people need and what technologies could meet them. Now the question is, which of these are we going to invest in? So what are the investors interested in? Again, the investor is automotive original equipment manufacturers. They're not the AI group in the garage in Stanford. These are large companies that have to make some decisions. What are they interested in? They're interested in competitive advantage. If I make an investment in one of the columns in the previous table, what does that do for me? Can I have value-added pricing? Can I reduce production costs or operating costs? And how can I leverage existing capabilities? They're also interested in a strategic fit. To what extent will the investment of interest leverage technology competencies, exploit current delivery architectures, complement existing value propositions, exploit current partnerships and infrastructure, and provide other opportunities for exploitation? Okay. And then finally, as you might expect, they're very interested in return on investment. What features will be needed? What will be the operating costs of delivering the solution? So, working with General Motors, we were looking at, okay, what's their choices? Well, one choice is they provide the total vehicle package, all the software, all the intelligence, all the sensors, et cetera. At the other extreme, down the bottom row, they provide the whole integrated surface. So not only do they build the vehicle with all the software and the intelligence, they actually provide the service to the end user, which they don't do now. Okay, so they're basically subsuming Uber, Lyft, and other kinds of services. The intermediate ones are interesting. Row 4, is provide the vehicle without an alliance. So basically build the car and hope that other people will adopt the car. I mean, not just the consumers, but the providers of the software online. The second column is provide the vehicle to host the intelligent software, but you align with Amazon, Apple, Google, Microsoft, or Uber so that you provide a joint offering. The third one is provide the vehicle to with an alliance with advocacy groups. For example, Ford had the Eddie Bauer Ford Explorer. GM could have the AARP autonomous vehicle. And so we've explored these 5 different investment scenarios, both in terms of what uncertainties, how confident are we in doing it, and what's our ability to respond? Can we really do this? And you might find it interesting that the first and the fifth one are by far the most profitable alternatives, but they don't make the cut. And you'll see that in a few minutes. So we come up with multi-attribute utility models, which we mentioned earlier, and we looked at varying the weights. The black column is what if finances is what matters totally. What if strategic fit matters? What if competitive advantage matters? What if ROI plus CA is the balance? And you can see here the different scenarios. Basically, scenario 1 and 5 really fade, lower utility. Okay, on the y-axis. Why do they fade? Well, it's interesting. They are by far the most profitable alternatives. Okay, they provide huge competitive advantage, but they have enormous risk. They have enormous risk of whether or not the company can actually execute. They also have enormous risk as whether the company can secure a competitive position in the market. The other three come out very strongly. Number 4 comes out the highest because it's what you know how to do already. There's no doubt that you can do this. There is some uncertainty about how much you'll make from it. The first one, the second one, second columns, etc. They're focused on you working with Google or whatever, and coming up with a team approach to this. And the third one is the ARP branded car. You might be interested to know that GM is actually executing multiple of these strategies. Their purchase of Cruise Automation a few years ago gives them a partner that they own. So, what's our strategy? Do we invest or not invest? We make a substantial investment in scenario 2. This is a hedge against market and technology risks because other people own parts of the market, the perceptions of the market that you don't, and they have mature technologies that you don't have. Scenario 3 is also a hedge. It's a hedge against scenario 2 not resulting in a partner. What happens if you try to team with Google, Apple, or whatever, and they're not interested? So we need a hedge against our hedge. And then finally, the baseline investment is acceptance of a traditional role in the automotive marketplace. We know how to do that. There's no doubt about it. We probably won't make the profits we could have with scenario 1 and 5, but they're too risky. So this is a summary. What we had to do to address this problem is, first of all, understand what are the phenomena playing out in this marketplace or mission place, if you will, that is laced with uncertainties, and what are the possible strategies we could employ. We did not include a strategy of invest versus not invest. The question is what type of investments. The major investment in scenario 4 is investments we're already making as an automotive OEM. The investments in scenario 2 and 3 are hedges against the uncertainties in the market. Okay, so we're actually investing in 3 ways. Our overall approach is using some very well-defined representations and using them as a basis for pursuing the whole notion of an uncertainty management advisor. We, by the way, have started to look at cases where you're not building a technology platform, you're trying to put together a policy portfolio. And so now it's rather, but it's the same approach applies. And then in the autonomous vehicle case study, we worked with General Motors, looking at their real needs, their real knowledge, their real concerns. We found their attributes of interest. We came up with alternative investment scenarios, and we came up with an overall investment strategy that involves 3 different investments. Now, what do we do about this? What do we conclude? Just as a wrap up here. The question of looking at a very uncertain market and deciding whether to invest or not invest is much too simplistic. The real question is how to invest, and how to invest with a portfolio of choices that hedge the uncertainties you have to face, but takes advantage of situations where you're less uncertain. Okay? We see this as something that will be done interactively. Certainly with GM, as we developed this, it was interactive meetings and sessions about what really matters and what are you concerned with. And we think that this is going to provide a better way to deal with uncertainty. In other words, we're not getting rid of uncertainty. That's impossible. We're not avoiding uncertainty. That's not realistic. We're coming up with a way of managing uncertainty to create a portfolio of investments that make sense in the context you're working in, whether it's automotive, autonomous cars, or defense missions. We really feel that what we've developed here applies broadly. Thank you very much.